Today, the complete network includes over 6,400 kilometers of transmission pipelines, 720 storage reservoirs, and more than 40 major pumping complexes. It delivers water to over 60 cities and towns. Every second, millions of liters surge through this steel cardiovascular system. Operating water infrastructure in Saudi Arabia means battling conditions that would destroy ordinary systems. Summer temperatures regularly exceed 120 degrees Fahrenheit. Equipment that functions perfectly elsewhere fails within months. Even the oil used to lubricate pumps breaks down in the extreme heat. Sandstorms pose another threat. The fine desert dust penetrates every opening, clogging filters, abrading seals, and contaminating electrical systems. Major storms can shut down operations for days. Engineers designed enclosed, pressurized buildings that keep the desert outside, even during the worst tempests. The seawater itself creates problems. The Persian Gulf is among the saltiest and warmest bodies of water on Earth. Warmer water is harder to desalinate. It requires more energy. Higher salinity means more salt to remove. Saudi plants operate at the edge of what the technology can handle. Marine growth constantly threatens intake systems. Barnacles, algae, and jellyfish clog the massive pipes that draw seawater into the plants. SWCC deploys underwater drones and diving teams year-round to clean intakes and prevent blockages that could halt production. Energy consumption is staggering. Desalination is energy-intensive. Saudi plants consume over 1.5 million barrels of oil equivalent annually just to produce fresh water. The kingdom is racing to transition toward renewable-powered desalination, using its abundant solar resources. Brine disposal presents environmental challenges. For every liter of fresh water produced, another liter of concentrated salt water remains. Saudi Arabia returns this hypersaline brine to the ocean through carefully designed diffusion systems that minimize impact on marine ecosystems. Security is paramount. The water network is critical infrastructure. Any disruption could threaten millions of lives. Armed guards protect major facilities. Sensors monitor every kilometer of pipeline for leaks or interference. Control centers track water flow in real time across the entire kingdom. Cybersecurity has become increasingly critical. Sophisticated computer systems control every pump, every valve, and every treatment process. Protecting these digital systems from hackers who might seek to disrupt water supplies requires constant vigilance and the most advanced digital defense technologies. SWCC has pioneered numerous innovations to address these challenges. Advanced membrane technologies reduce energy consumption by 30%. AI systems predict equipment failures before they occur. Hybrid plants combine MSF and RO technologies to optimize efficiency in the extreme conditions. The newest plants incorporate renewable energy from the start. The planned NEOM desalination facility will be powered entirely by solar and wind. Saudi Arabia aims to produce 50% of its desalinated water using renewables by 2030, the largest green desalination program ever attempted. The transformation of Saudi Arabia is visible from space. Where satellite images once showed endless brown desert, now green agricultural projects dot the landscape. Cities that could not exist without desalinated water have become home to millions. The impossible became ordinary. The economic impact defies calculation. Every industry, every farm, every hospital depends on desalinated water. The $80 billion invested in water infrastructure has enabled trillions of dollars in economic development that would otherwise have been impossible in this waterless land. Saudi expertise is now exported globally. SWCC and Saudi engineering firms build desalination plants across the Middle East, Africa, and Asia. The techniques developed in the harshest environment on Earth now bring water to millions in other water-stressed regions. For ordinary Saudis, the engineering miracle has become invisible. Children born today have never known water scarcity. They turn taps and water flows. They don't realize that every drop traveled hundreds of kilometers through giant pipelines, transformed from undrinkable seawater by billion-dollar technology. The infrastructure built over 50 years continues to expand. New plants come online annually. Pipeline networks extend further into once unreachable regions. By 2025, Saudi desalination capacity will exceed 8.5 million cubic meters daily, enough for a population twice its current size. Vision 2030, Saudi Arabia's modernization plan, includes massive water infrastructure investments. New megacities like Neom will require entirely new water networks. The kingdom is planning for a future where 50 million people can thrive in a land where nature provided water for thousands. The workers who built this system, pipe welders who labored through desert nights, engineers who solved impossible problems, operators who keep water flowing every second of every day, they are the unsung heroes of Saudi Arabia's transformation. Their legacy flows through every tap. As climate change intensifies and water scarcity threatens billions worldwide, Saudi Arabia's example becomes increasingly relevant. They proved that geography is not destiny, that technology can overcome nature's limits, that human ingenuity can create abundance where only scarcity existed. The Persian Gulf and Red Sea crash eternally against Saudi shores, vast, salty, and seemingly useless for human life. But through giant pipelines stretching thousands of kilometers, those ancient waters now sustain a modern nation. The ocean became a reservoir, the desert became a home. From the pumping stations pushing water over mountains to the control rooms monitoring every drop, from the midnight welders to the marine biologists protecting ecosystems, this is a human achievement without parallel, a nation that refused to accept the limits nature imposed. Every day, 11 million cubic meters of fresh water surge through steel arteries across the Arabian Peninsula. Billions of liters created from the sea, pumped through pipes that could swallow trucks, lifting water over mountains, sustaining life where only death should exist. And in cities across the kingdom, in Riyadh, in Jeddah, in Mecca and Medina, millions of people wake each morning to a miracle they no longer notice. Water flows, life continues. The desert, conquered by engineering, surrenders to human determination. How Saudi Arabia pumps billions of liters of seawater through giant pipelines into their desert nation? Not through luck, not through divine intervention, through vision, investment, and engineering that refused to accept that water cannot flow where nature forbade it. The pipelines still surge, the plants still roar, the water still flows, and a kingdom that should not exist thrives in the heart of the world's harshest desert. Saudi Arabia's water miracle, proof that when humanity decides something will be done, even the impossible must yield. In the heart of the Arabian Peninsula, where summer temperatures soar past 130 degrees Fahrenheit and rain may not fall for years, lies a kingdom that should not exist. A nation of 35 million people living in one of the most hostile environments on Earth, Saudi Arabia. This country has no permanent rivers, no natural lakes. Rainfall averages less than 4 inches per year, 10 times less than the Sahara Desert. Yet, Saudi Arabia doesn't just survive, it thrives, with gleaming cities, lush gardens, and water flowing from every tap. The secret? The largest desalination operation in human history. Every single day, Saudi Arabia pumps over 11 million cubic meters of seawater from the ocean, transforms it into fresh water, and sends it surging through 8,000 kilometers of giant pipelines into the desert. The scale is almost incomprehensible. Over 5.6 billion liters of fresh water created from the sea every day, enough to fill 2,200 Olympic swimming pools, pumped across a nation twice the size of Egypt through pipes large enough for trucks to drive through. This is not merely infrastructure. This is survival engineering on a scale the world has never seen. A multi-billion-dollar network that transforms the Persian Gulf and Red Sea into the lifeblood of a modern nation. This is how Saudi Arabia conquered the impossible. To understand how Saudi Arabia built this water miracle, we must first understand the crisis that made it necessary. a crisis so severe that the kingdom's very existence depended on solving it, and the extraordinary engineering that made survival possible. For thousands of years, life in Arabia centered around oases, rare pockets of groundwater that could support small populations. Nomadic tribes traveled between these precious water sources. Cities existed only where wells could reach ancient aquifers hidden deep beneath the sand. When oil was discovered in 1938, everything changed. Suddenly, Saudi Arabia had the wealth to build modern cities, attract millions of workers, and dream of transformation. But wealth meant nothing without water, and ancient aquifers were already running dry. By the 1970s, Saudi Arabia faced a stark reality. Underground water reserves that had accumulated over 20,000 years were being pumped out in decades. Cities like Riyadh, 500 kilometers from the nearest coastline, were growing faster than any water source could sustain them. The solution seemed impossible. Bring the ocean inland. Build desalination plants on the coasts that could remove salt from seawater, then pump that fresh water hundreds of kilometers across one of the harshest landscapes on Earth to cities that desperately needed it. In 1974, the Saudi government established the Saline Water Conversion Corporation, SWCC, with a mandate to make the impossible possible. Their mission? Build the largest desalination and water transport system the world had ever seen. Budget? Virtually unlimited. Failure? Not an option. Engineers from around the world were recruited, from America, Japan, Korea, and Europe. They faced challenges that seemed insurmountable. How do you build in 130-degree heat? How do you prevent pipelines from bursting under thermal stress? How do you move water uphill for hundreds of kilometers? The planning phase took years. Engineers surveyed every kilometer of the proposed pipeline routes. They studied soil conditions, mapped elevations, calculated pump station requirements, and designed systems that could operate in conditions no water infrastructure had ever faced before. The first major project was connecting the eastern coast to Riyadh, a 466-kilometer pipeline through brutal desert terrain. It would be the longest water pipeline ever constructed in the Middle East. Construction began in 1978, and what followed was an engineering epic. Before water could flow through pipelines, it had to be created. Saudi Arabia embarked on constructing the largest desalination plants ever built. The first mega facility rose at Jubail on the Persian Gulf coast, an industrial complex spanning over 800,000 square meters. These plants use a technology called multi-stage flash distillation, MSF. Seawater is heated until it flashes into steam, leaving salt behind. The steam condenses into pure fresh water. The process repeats across 20 to 30 stages, extracting maximum fresh water from every drop. The scale of each MSF unit is staggering. Single evaporators stretch over 100 meters long, containing millions of tubes where heat transfer occurs. The steam generated could power a small city. The salt extracted could cover football fields in White Crystal Mountains. Modern Saudi plants also employ reverse osmosis, the same technology Israel pioneered, but at even larger scale. Ras Al Khair, opened in 2014, combines both technologies into a single facility, producing over 1 million cubic meters of fresh water daily. Ras Al Khair is a city unto itself. The facility employs over 3,000 workers. Its power station generates 2,400 megawatts, enough electricity for 2 million homes. The intake pipes draw 4.5 million cubic meters of seawater from the Gulf every single day. On the Red Sea coast, the Shuaiba complex mirrors this scale. Together, Saudi Arabia's 31 desalination plants form a crescent of water factories stretching along both coastlines, the largest coordinated desalination network in human history. The construction of these plants required importing components from around the world: massive evaporators from Japan, precision pumps from Germany, membrane systems from America. The logistics alone, transporting million-ton equipment to remote desert coasts, was an engineering feat unto itself. But producing fresh water at the coast was half the challenge. The cities that needed it most, Mecca and Medina, lay hundreds of kilometers inland, across some of the most forbidding terrain on Earth. The water had to travel through giants. The pipelines that carry water across Saudi Arabia are unlike anything else ever built. Some measure up to 3.5 meters in diameter, large enough to drive a car through. Constructed from reinforced steel with walls up to 25 millimeters thick, designed to withstand pressures exceeding 25 bar. Each pipe section weighs over 20 tons and must be transported individually across roadless desert. Specialized pipe-laying vehicles, some stretching 50 meters long, carry these sections to remote installation sites. A single pipeline requires thousands of individual welds, each tested for perfection. Installation happens at night. During Saudi summers, daytime temperatures cause steel to expand so dramatically that precise welding becomes impossible. Crews work from sunset to sunrise, racing against the heat. When dawn arrives, work stops. The desert belongs to the sun. Thermal stress remains a constant enemy. Desert temperatures can swing 50 degrees between day and night. Pipelines expand and contract with each cycle. Engineers installed massive expansion joints every few hundred meters, steel accordions that absorb movement without breaking the seal. Corrosion protection is equally critical. Pipelines are coated with layers of epoxy and polyethylene, then wrapped in protective concrete or buried beneath the sand. Sacrificial anodes, zinc blocks that corrode instead of the steel, protect the pipes electrochemically for decades. Moving water hundreds of kilometers requires immense energy. Saudi Arabia built over 40 major pumping stations along the pipeline routes. Each pump contains pumps the size of houses, capable of moving 80,000 cubic meters per hour. The electricity consumption rivals small cities. The water must climb. From sea level at the coast, pipelines ascend over 900 meters elevation at Riyadh. This isn't a gentle slope. The terrain includes mountain ranges, wadis, and rocky plateaus. Pump stations are positioned strategically to push water uphill stage by stage. At peak operation, water travels at over 2 meters per second through these arteries. The journey from the Gulf Coast to Riyadh takes approximately 72 hours, 3 days of racing through the desert before a single drop reaches a tap in the capital. The pipeline network eventually grew to over 8,000 kilometers, enough to stretch from Saudi Arabia to London and back. Multiple parallel lines ensure redundancy. If one pipeline fails, others compensate. The network has no single point of failure that could leave cities dry. Massive storage reservoirs dot the landscape. The largest hold over 12 million cubic meters, equivalent to 4,800 Olympic pools. These provide crucial buffer capacity during peak demand or maintenance shutdowns. The water system can operate for days even if coastal production stops entirely. For the holy cities of Mecca and Medina, additional dedicated pipelines were constructed. During Hajj, when millions of pilgrims descend on these cities, water demand spikes dramatically. The system must handle surges of 500% above normal without any disruption to